So which we have discussed about the the data analytics for IoT. That is next we are going to study about the overview of the IoT technologies. That is the IoT analytics for the overview. Okay. So these what are the that is what we have studied a descriptive four kinds of data analysis: descriptive, diagnostic, predictive, and prospective. Okay. Now data analytics for the IoT is next is about the what are the challenges that we are going to face when we are going to get a huge amount of data and challenges. As IoT has grown and evolved, it has become a clear that traditional data analytics solutions were not always adequate. For example, if you take a traditional data analytics typically employs a standard RDBMS and corresponding tools, but the world of IoT much more demanding. While relational databases are still used for certain data types and applications, they often struggle with the nature of IoT data. IoT data places two specific challenges on RDBMS, right? One is the scaling problems, okay? The other one is volatility of the data. So what is a scaling problem? So as I told that IoT sensors or the IoT devices, they produce huge data, right? Due to the large number of smart objects which are connected in most IoT networks that continually sending the gigabits of data for every second. So relational RDBMS can grow incredibly large very quickly. This can result in performance issues that can be costly to resolve, often requiring more hardware and architecture changes. Okay. So this can result in performance issues that can be costly to resolve, and they require more architecture and the hardware changes. Okay. Now next is that is volatility of the data. With respect to the RDBMS, it is very critical that scheme be designed correctly from the beginning. We have to design that the schema from the beginning. Okay, changing it later can slow or stop the database from operating. Due to the lack of the flexibility, revisions to the schema, so we have to keep it as a minimum. So if you are going to keep it as a maximum, maybe you are going to lose the data. Maybe it is going to stop the process itself, right? However, it is when we are going to say it is a volatile in the sense that data model itself is likely to change and we may change over time. A dynamic schema is required so that data model changes can be made daily or even hourly. Also, we can change it. To deal with these challenges like scaling and the data volatility, so we can have different type of database known as NoSQL. It is being used. So that is SQL, as we are already familiar in DBMS, that is a structured query language. It is the computer language used to communicate with your RDBMS. This is a one language where we are going to communicate with RDBM by writing some SQL statements. As the name implies, NoSQL database is a database that does not use SQL. It is not set up in the traditional tabular form of a relational database. So NoSQL is a database that do not enforce a strict schema, and they support a complex evolving data model. These databases are also inherently much more scalable. For more information on SQL, okay, in addition to this relation RDBMS, okay, challenges that IoT impose with high volume of smart object data that frequently is keep on changing. IoT also brings such challenges with the live streaming nature of its data with managing data at the network level. The streaming data which we are going to study the data which we are going to study, which is in the data in the live, we can say, right? And with the managing such data in the at the network level is very complex process. When that is a complex process, when they're in the complex process, managing of such data, the network level is very difficult. Okay. So this IoT also being challenges with the streaming nature of the data and with managing the data at the network level. Streaming data which is generated as a smart object transmit data is challenging because it is usually very high volume and it is data whatever we received is a valuable data only if it is possible to analyze and respond to it at the real time. Okay, so we have to do that analysis at the real time itself. Real time analysis streaming data allows you to detect patterns or anomalies that could indicate a problem or a situation that needs some kind of immediate response to have a chance of affecting the outcome of this problem. You naturally must be able to filter and analyze the data while it is occurring as close to the edge as possible. The market for analyzing streaming data in a real time is growing fast. Major cloud analytics providers such as Google, Microsoft, IBM have streaming analytics offerings and various other applications can be used in-house. So edge stream analytics what we discussed in the previous sections. Okay. So another challenge that IoT brings to analytics is in the area of network data, which is we are going to refer as a network analytics. With a large number of smart objects in IoT networks that are communicating and streaming the data, that is, it can be challenging to ensure that these data flows are effectively managed, monitored, and they're secured. Network analytics tools such as NetFlows, IPFix provide the capability to detect the regular patterns, that is we can call structured data, or other problems in the IoT data through a network. Network analytics, including both flexible net flow and IPFix, is going to be discussed in detail in the next sections. Next, we'll study how this machine learning is going to handle the different techniques are going to be used to handle the unstructured data which is produced by the IoT network. Okay. See, this machine learning is one of the core subject in IoT as it is because we are going to use some of the machine learning algorithms in order to handle that huge data, unstructured data, because the data will be in the form of a text or in the form of a speech or in the form of a video or in the form of a some other way, right? So whatever the data is generated because of this much data can incomprehensible to naked eye. We need specialized tools and algorithms to find the data relationship that will lead to new business insights. So this brings us to study the machine learning. Okay, machine learning, deep learning. As I told, machine learning is a central to IoT, right? Data which is collected by the smart object needs to be analyzed, and that data we have to take some intelligent actions to need to be taken based on these analysis. When you are going to perform this kind of operation manually, almost impossible or very slow or inefficient. Okay, so machines that are needed to process information fast and react instantly when the threshold are met. For example, every time a new advance is made in the field of self-driving vehicles, abnormal pattern recognition in a crowd, or any other automated intelligent and machine assisted decision systems, ML is named as a tool that made the advance possible, but the machine learning is not new. It was invented in the middle of 20th century, and actually it has fell out of the fashion in 1980. So that has happened in the ML that makes it the new tool of choice for IoT and data analytics. Okay. So then when we are going to look at the machine learning overview, machine learning in fact is a part of larger set of technologies commonly grouped under term called as artificial intelligence. As I'm telling that machine learning is a sub branch of artificial intelligence. Okay. This term used to make science fiction dream piped robots and conscious machines, or a matrix-like world where machine would enslave humankind. In fact, it mimics the human intelligence. As I told, AI includes any technology that allows computing system to mimic like a human intelligence using any technique, from very advanced logic to the basic if-then decision loops also. Any computer that uses rules to make the decision belongs to this realm. Okay. Machine learning that makes it a new tool for choice of IoT and data analytics. So that is as I told that it is a logic based if in use rules make the decision. A simple example is an app that can help you to find your parked car. We can use a GPS reading of your position at a regular intervals, calculates your speed. A basic threshold system determines whether you are driving. For example, if the speed is greater than 20 mph or 30 kilometers per hour, Then start calculating the speed. When you park and disconnect from the car, Bluetooth system, the app what you are installed in your mobile simply records the location when the disconnection happens. This is where your car is parked. Behind the appearance of AI, that is artificial intelligence, the computer knows that you are parked and where it has happened. That rule set is very simple. So what happens in more complex cases? Okay, static rules cannot be simply inserted into the program because they require some parameters that can change or that are imperfectly understood. A typical example is a dictation program that runs on a computer. This program is configured to recognize the audio pattern of each word in a dictionary, but it does not know your voice specifics, your accent, tone, speed, and so on. You need to record a set of predetermined sentences to help the tool match well-known words to the sounds you make when you say the words. This process we call it as a machine learning. So ML is concerned with any process where computer needs to receive a set of data that is processed to help perform a task with more efficiency. ML is a vast field but can be simply divided into two main categories: supervised and unsupervised learning. Okay. So that is supervised and unsupervised learning. Let me know what is the difference between supervised learning and unsupervised learning. So when you come to the supervised learning, the machine is trained with the input for which there is a known correct answer. Okay. So this machine is trained with by giving some input. For example, if you take that you are training a pro system to recognize when there is a human in mine tunnel. Okay. A sensor equipped with basic camera can capture the shapes and return them to a computing system that is responsible for determining whether the shape is a human or something else, such as a vehicle or pile or ore or rock or piece of wood or so on. With supervised techniques, hundreds or thousands of images are fed into the machine, and each image is labeled human or non-human in this case. This is called training set. An algorithm is used to determine common parameters and common differences between the images. The comparison usually done at the scale of the entire image, or pixel by pixel images are resized to have the same characteristics, that is a resolution, color, depth, position of the central figure, and so on. And each point is analyzed. Human images have certain types of shapes and pixels in certain location with a different angles they are going to take, and the good images and which corresponds to the position of the face, legs, mouth, and so on. Okay. So each new image is compared to set of known good images. So it is going to determine the shape of the position in the face, legs, mouth, and so on, because you can differentiate the animal shape and the human shape and the place where the face, legs, and mouth is going to mounted, right? Each new image is compared to the rest set of known good images, and a deviation is calculated to determine how different the new images is from the average human image, and therefore probability that what is shown is a human figure. The process we call it as a classification. After training, the machine should able to recognize the human shape. Before real field deployments, the machine is usually tested with unlabeled pictures. This is called the validation or test set. Depending upon the machine learning system used a variety of recognition levels at acceptable thresholds. If the machine does not reach the level of success expected, more training is needed. In other cases, the learning process is not about classifying in two or more categories, but about finding a correct value. For example, if you take the speed of the flow of oil in a pipe is a function of the size of the pipe, the viscosity of the oil, pressure, and few other factors. When you train the machine with the measure values, the machine can predict the speed of the flow for a new and unmeasured viscosity. This process is called regression. Regression predicts numeric values, whereas classification predicts the categories. Okay. So supervised learning is we are going to deploy more training is needed. Okay. In other cases, the learning process is not about classifying two or more categories, but it is the finding the correct value. If you take a press example, as I told, pipe is a function of the size of pipe, viscosity of the air pressure, and fee. And the regression predicts numeric value, where the classification predicts the categories. This process we call it as a regression. Okay. So this is about a supervised learning, where you are going to provide the training set, well-defined training set as a input. And when you are going to, we are going to compare that the whatever the images we have input with the other things, then we can recognize that whatever we have set is threshold value is in a proper way or not. Okay. So certain location which corresponds to the position of the face, because animal faces will be in the different position and their legs will be in the different position and their mouth will be in the different position, right? When we are going to compare with this different positions of the face, legs, and mouth, so we can easily identify it is a shape of the human being or an object or an animal or a rock or a wood or any other object. Okay, that is what we can say is a supervised learning. We designate that when you are going to input the trained data, okay, we call that as a supervised learning.